What we're checking then is that this value is greater than, and now we're going to create a threshold value to be compared with. Now to do this, we're going to use another capability of the event wizard. What we're going to do is pick channel 1 alpha amplitude, which is actually the same as the value A. But if you look to the right, what we've done is we've applied a damping factor, and this damping factor is 20. A damping factor of 20 means the value is going to be averaged over about the previous 20 seconds. So it's a damped or time averaged value. The event will be to play a MIDI sound, and if we look over to the right, we see that we've chosen an appropriate set of MIDI sound qualities. We've picked a note and an instrument organ, etc., similar to the previous example. And let's run this protocol and then see what happens when we train a variable against its damped value. So we hit use these settings, run the next session, go. Now again, if we review the text, we see that value A, the antecedent, is simply alpha minus 2 microvolts. The rule is greater than. The value B is the channel 1 alpha microvolts, and we recall that we damped it. And then we see a summary of the values. The A value is changing in time. The B value is also changing in time since this is now a dynamic threshold. We see the percentage of time it's satisfied. And if we look at the graph on the right, what we see is that the alpha amplitude is going up and down, and the green value, which is its threshold, is also moving up and down, and it is the time average or damped value. So what we've done quite simply is by creating a single English language expression, we've told the system we want to compare the alpha amplitude with its damped value, and we provided an offset of 2 microvolts, and now we've instantly provided dynamic thresholding and the ability to train alpha amplitude up. And at the same time, we're monitoring the percent time over threshold. As another example, we can go back to Viewer Change Settings, Read Write Settings file, and let's look at Demo Alpha Asymmetry with rising flute tone. Read in settings from this file, hit OK, use these settings, and let's look at the event wizard briefly. In order to create an asymmetry protocol, we quite simply have said if channel 1 alpha amplitude, damping factor 20, is less than channel 2 alpha amplitude with the same damping factor, then play a MIDI sound. We've chosen a slightly different sound this time. We're going to use the shakuhachi flute. We're also going to use amplitude and pitch modulation at the same time, with a loudness change rate of 10 and a note change rate of 1, and we've picked a major scale. So we will now use the settings, run the next session, go. And now what we see, again reviewing the English language summary, if channel 1 alpha amplitude is less than channel 2 alpha microvolts, also amplitude, then play a tone. We see the two values now in real time. We see the percentage of time the condition is met. And then let's watch the display. Well, channel 1 is being displayed in white. Channel 2 is being displayed in green. Channel 2, since it's the threshold, we see the number displayed here. And we find that we have tones occurring whenever channel 1 is below channel 2. So again, this is an example of a very simple way to design an asymmetry protocol that using any other technique would be much more difficult to design. Let's look at another protocol. Viewer Change Settings, Read Write Settings file. Let's look at this, Demo Alpha downtraining with multiple thresholds, organ and piano. Read in settings and look at the event wizard. Now what we're going to find in this is that more than one event are being used. The first event says if channel 1 alpha amplitude with a damping factor of 10 is greater than 6, then play a MIDI sound. And we've picked note 49, an A with an organ for that event. Now, if we go to the event selector along the top and press event 2, we'll see that event 2 is also being used. It says if channel 1 alpha amplitude is less than 6, then play a MIDI sound, and in this case we've chosen piano. Similarly, we can look at event 3. Event 3 is the same, except the constant, the entered value has been used as 5.5, and we're using a different note. We're using G sharp. We go to the fourth event. It's also defined. The entered value is 5, and the note is an F sharp. Now we'll look at event 5. There the value is 4.5, and the note is E, note 44. Event 6 is also defined. The entered value is 4, and there the starting note is D. So this protocol has been pre-set up for us with multiple events, each event containing its own conditions and comparison values and its own notes. These events are all going to work together to produce a multiple thresholded protocol.